All right, hi everyone. Today we are working on long division. All right, so let's do a quick review before we go into long division. Let's see where we're from. Okay, so we start off with a problem. Let's say x equals to 2, 3, and -1. These are our roots that we talked about before. These are, let's say, were the solutions, and we work backwards and we say, hey, what were the factors? It's x minus 2, x minus 3, and an x plus 1. These were the factors, right? And then we can multiply this out. So I'll do this quickly. This is going to be x squared minus 5x plus 6. And then we're going to multiply this by x plus 1. So going forward is pretty easy, right? We worked on this on your IXL. You multiply x times x, and then x times 3, 2 times x, and 2 times 3. And -2, -3 is -5. That's how it ended up with -5x in the middle. And I'm going to multiply this out again. X cubed minus 5x squared plus 6x. And then multiply this by 1. We have x squared minus 5x plus 6. And we end up with x cubed minus 4x squared plus x plus 6. And this is where we're going to start our story today. It's easy to multiply to go forward, but it's hard to go backwards. If this was x squared, we had a lot of tools of how can I factor x squared problems. But when it came to x cubed problems, it's almost like we just took a step over a cliff and we're falling and there's no way for us to get back up because we're falling now. And for x cubes, there's no nice factoring technique. We use other methods to simplify the problem. And I want to show you the methods that we used back in 3rd grade. So let's talk about some numbers. Like if I give you the number 36, okay, if I give you the number 36, how do you find the factors of 36? You could know the multiples of 36, but another way is you would just start dividing numbers. You say, hey, can I divide 36 by 2? Yes, you can. So we would divide 36 by 2. And that would give us 1. Okay, let's look at I'm going to real quickly go through the steps of long division. We match. Then the second step here is we multiplied downward. Okay? So match, then multiply. And then the third step is we subtract. And then we subtract. These are our 3 steps that we work with when we're doing all these steps. We match, multiply, and then subtract. We match to try to get as close as we can to that front number, and then we multiply down, and then we subtract to see what we have left over. Then we repeat. We match. Now this number is 2. We multiply downward. We end up with, sorry, not 2. What am I talking about? It's 8, right? I don't know why I said 2. This is 8. We match. 2 times 8 is 16. We multiply downward. We end up with 16 here. And then we subtract. And we end up with 0. So the 3 steps we did for long division before are the same steps that we're going to, for regular long division with numbers is actually a trick that we're going to do to factor out this problem. To find factors, we just divided. And we sometimes would end up guessing what values we would divide by. If I give you the number, let's go give you guys another number here just to talk about long division. 1, 2, 5, 2, okay? And let's give you guys one more number, 1, 2, 5, 2. Let's give it a 3. 2. Okay, so I have a number 1, 2, 5, 2, 3, 2. Right? This is a huge number. And I want to say, what are the factors of this crazy number? And we would start randomly dividing. And so there's some characteristics here. What number would you look at first, probably? Well, what's the easiest number to divide any number by? By 2. And if this was even, we could divide by 2. So let's go ahead and do that. We're going to do our skills. We're going to divide this by 2. We're going to match. So 2 goes into 12 6 times. We multiply downward. And then we subtract. 0. Bring down the next term. We match. The best we can match is by 2. 2 times 2 is 4. We multiply and then we subtract. We match. we multiply, and then we subtract, we match, we multiply, and we subtract, we match, we multiply, and then we subtract, right? And this is the method we went through over and over and over. Once we're done with this, we take this number and then we try to divide this number again by a different number. So to just talk about this in a very basic way is that to factor funny numbers that we don't know anything about, we just pick a number and we try our best. And we use a couple of hints the best we can looking at that last number. And that's what we're going to do here. So I'm going to teach you guys how to do long division today. And that's going to help us factor this crazy x cubed problem. And it's something that we also learned in algebra 2. So here we go. The first thing I'm going to factor out, so I'm going to divide out x minus 3 from x cubed minus 4x squared plus x plus 6. Now, we have two ways of factoring a large polynomial like x cubed and above, and that's going to use synthetic division or long division. And today's method is we're going to work with is long division. Okay, so let's go through our steps. First thing you want to do is match, but please be aware, we're only going to match the front number to our term that we're working on. Okay, we're only going to match that front number. The 3 is great, but we're not going to match it. So how can I get x here to look like x cubed? What could I multiply x by to become x cubed? I need x squared. You might say, Mishko, why would we use x squared? Because x squared times x cubed in our next step gives us x cubed. X squared times x becomes x cubed. Now, please be aware that we are multiplying both terms, and that's going to be negative 3x squared. Because it's x squared times not just x, but x minus 3. And that's our method. We're going to match, we multiply, and then our next step is we're going to subtract here. I want to show you something. When I do subtract, I always draw a parentheses and a minus sign. And I highly recommend you do that too. You want to remind yourself that we're subtracting both terms, x cubed and x squared here. If you don't write the parentheses, you're probably going to forget. Now, here's the next easy step. I change the signs right away. I'm going to write a negative. Isn't a positive times a negative times a positive? Negative. And what's negative times negative? Positive. So I'm actually going to change the signs right here. Take a look here. I'm going to write the signs right on top. So I notice what's x cubed minus x cubed? That's going to be 0. What is negative 4 plus 3x squared? Negative 4 plus 3x squared? That's going to be a negative x squared. Bring down the term. All right. That looks good. Let's go ahead and restart the order. We're going to try to match the front number to this front term. In this case, we're going to need a, not just an x, we're going to need a negative x. So we match. We multiply downward. This is going to be negative x squared minus, becomes a positive 3x. Negative is a positive. And then we're going to subtract now. Match, multiply, subtract. This becomes a positive and a negative. Please take a note. I write my signs on top just so I can visually see them. If I visually see them, I make less mistakes. And then we combine them. Negative x squared and x squared cancel out like our goal is. And we have left over a negative 2x plus 6. Okay, negative 2x plus 6. Let's continue this. We match. We multiply. And then we subtract. Take a look at the signs. They're going to all cancel out. Negative 2x, negative positive 2x, and 6 and negative 6. 0. 0 remainder. Now, the next part of this is a discussion, how do I write the answer? The answer to this, what is x cubed minus 4x squared plus x plus 6 divided by x minus 3 equal to? This is equal to x squared minus x minus 2. Okay, so if I divide it, if I'm dividing these two, we're left with this. And that's really the method of long division. That's it. Nothing special. There is a question though that often happens. A lot of people will rewrite this the wrong way. And it's because they're mixing up the question of this. Am I dividing or factoring? If I write factor x cubed minus 4x squared plus x plus 6, the factors are x squared minus x minus 2 times x minus 3. If I'm asking you to factor something, I want all the parts that multiply back to the original problem. So if I'm asking you to factor, I want you to write down all the pieces. And doesn't x times x squared become x cubed? So please don't mix up the terminology. If I ask you just divide, we end up with this guy here. But if I ask you to use the word factor, you not only have to write what our answer was, but also what we divided by. And let's use the term in factoring a little as we've seen before. If I say, what are the factors of 12? The factors of 12 are 2 times 2 times 3, right? But if I said, what is 12 divided by 4? That's just 3. These are different questions, so be careful when you are asked to either factor or even use long division to help you factor. Answer the question. If I say factor, I want all the parts back. If I say divide, just divide it. I don't want the parts back. These guys cancel it out. 4 times 3, the 4 divided out, leaving me a 3. That's a big mistake that kids fall into. Okay. Let's look at some IXL questions here. Here's an easy one. If I say b, 4b plus 28 divided by b plus 7. So it's top and bottom, okay? That's the idea. That's top and bottom. Or inside out. Inside is 4b plus 28. Outside is b plus 7. If we're asked to do long division, we're going to match first. What can I match 4 to become 4b? Well, I need a 4 in it. And then we multiply 4b plus 28. And then we subtract. And that becomes 0. Turns out, answer is 4. This answer here is 4. But why is it 4? Why is it, how can it be so simple? Well, something you want to note. If I write 4b plus 28 over b plus 7. Okay, let's look at this as a different way of doing division. What's a common factor in 4 and 28? That's common value of 4, right? Left over b plus 7. b plus 7. These both divide out, leaving me 4. So could you have skipped long division and just done factoring? Yeah, you could have. But that's not always an obvious case. If I look at this problem here, a 6q cubed plus 56q squared, this is a q, sorry about that, plus 18q, and divide this by q plus 9. Okay, that's a 9 here, and that's q. Now, I mean, this seems like a lot of work. But, okay, you know what? Let's just do it. And then we'll look at the easy way. Q plus 9 divided by 6q cubed plus 56q squared plus 18q. Okay, we follow the steps of long division. Match, multiply, subtract. Just like what we did before. If you ever forget, do a long division. Do 3 divided by 24. You match, you multiply, and then you subtract, right? All the same steps here. So let's match first. To get from q to 6q cubed, I need a 6q squared. Multiply down, 6q cubed, plus 6 times 9 is a huge number. That's 54q squared. We match, we multiply. Now last step is subtract. I write my signs on top, so I see them. Let me change the color so you guys can see them. That's a minus, and that's a minus. And we're left with 2q squared plus 18q. we're done. Let's go ahead and recycle our moves. Match, multiply, subtract to get from q to 2q squared. That's 2q. Match, multiply, subtract. We're going to multiply down. 2q squared plus 18q. Lucky for us, that subtracts out to be 0 remainder. Now, if you want to think smarter than harder, you might have noticed a couple of things. First, looking at 6q plus 56q squared plus 18q over q plus 9, I see some terms that seem like some easy terms here. Well, don't they all have a 6 here? Well, maybe not this one. Okay, they don't all have a 6, do they? Wait, do they? 56. No, they don't all have a 6. Let's factor out for sure I can get a 3 out. And no, I can't get a 3. I can get a 2 though. Did I copy this wrong? No. Oh yes. Okay, so I can take out a 2 if you want, and 2q. We're left with 3q squared plus... Wait, I can't even take out... I can take out a 2, and that becomes a 28q. I should write this a little bigger, I'm sorry. 29, the 2q, 3q squared plus 28q plus 9q. Q plus 9. And then if you notice, I'm not sure you need, I lost a... I can factor this to be 3q, q, and 9 and 1, plus and plus. That's factorable. So 2q, 3q plus 1, and that's our factoring technique. And these would divide out, leaving me 2q, 3q plus 1, which is the same answer as this guy here. But that takes us another approach through factoring. Okay. So I have one more thing for you guys, and pretty much we're done. It's that if we have a remainder, so let me go through a remainder. If I say 1, 2, 3 divided by 2, or 1, 2, 3 divided by 2, whichever way you want to write it. If I write 1, 2, 3 divided by 2, match, multiply, subtract. Match, multiply, subtract. Now, how do we write the remainder? We can write as remainder 1, right? That's one way of writing a remainder. But what we're really writing is 61, remainder 1 out of 2. If I give you an easier problem, if I say, what is 10 divided by 3? That's 3, remainder 1 out of 3. We always write what we're trying to divide by as a fraction of our remainder, because we tried to divide it, but it just didn't work. I have 1 out of 3. If I have 3 out of 3, we wouldn't have a remainder. So let me give you a way of writing remainders with polynomial division. So if I say x squared plus 3x plus 1 divided by x plus 1, okay? This is going to be written. This is not factorable, okay? X squared plus 3x plus 1 divided by x plus 1. First step is to match. X times what is x squared? X times x is to match. We multiply. And then we subtract. Take a look, I'm going to change my signs right on top. 3 minus 1 is 2x plus 1. Match, multiply, subtract. We then match again with the 2. 2x plus 2. We multiply down and then we subtract. Now be careful here. We have a remainder of negative 1. Now I'm going to show you, this is all you have to do for remainder. We have a remainder of negative 1 out of x plus 1. Please take a look at how I did that. We said the remainder is 1 divided by what we were trying to divide by. It's exactly the same thing as this up here. 10 divided by 3 is 3. Remainder, 1 out of what were you trying to divide by? By 3. In this case, I tried to divide by x plus 1. So we always write a remainder over that fraction of what we were trying to divide. And that's it. Easy peasy. Now, your homework today is pretty much this. It could get a little long. It could be x cubed, x fourth, but it doesn't change the process. It's still match, multiply, and subtract. And I think we're going to stop here and let you guys practice this over Excel. If you guys have any questions, you guys are free to ask. Let me know what I can help you with, okay? Thanks.